Why does a colossal steel ship float effortlessly on the ocean's surface, while a tiny pebble dropped from your hand plunges instantly to the depths? What invisible force dictates the fate of everything submerged, from the mightiest iceberg to the smallest grain of sand? This isn't magic. It's a fundamental truth of our universe, discovered by a brilliant mind over 2 millennia ago. Imagine stepping into a bathtub, watching the water level rise. That displaced water isn't just moving aside, it's telling a story. The ancient Greek polymath Archimedes observed this very phenomenon and unlocked one of the most profound principles in physics. He realized that when an object is immersed in a fluid, it experiences an upward push. This upward push, known as buoyant force, is precisely equal to the weight of the fluid that the object displaces. It's a simple concept with monumental implications. This force is what allows things to float, to sink, or to hover in perfect equilibrium. The buoyant force acts against gravity, constantly trying to lift an object. Whether an object floats or sinks depends entirely on its density compared to the fluid it's in. If an object is less dense than the fluid, it displaces a weight of fluid greater than its own weight, and so it floats. Consider a hot air balloon. It floats because the air inside the balloon is heated, making it less dense than the cooler air outside. The balloon displaces a volume of cooler, heavier air, generating enough buoyant force to lift its basket and passengers. Submarines, on the other hand, manipulate their density by taking on or expelling water, allowing them to dive or surface at will. Even icebergs, massive structures of frozen water, float because ice is less dense than liquid water. Only about 10% of an iceberg is visible above the surface, a stark reminder of the immense buoyant force at play beneath the waves. This principle is a constant, unwavering law of nature. Archimedes' principle isn't just for ships and submarines. It's woven into the fabric of our daily lives and the very world around us. It explains why we feel lighter in a swimming pool or why a life vest keeps us afloat. Our own bodies, filled with air in our lungs, are naturally buoyant in water. This principle is critical in countless engineering marvels, from the design of offshore oil platforms to the stability of bridges built over water. It guides meteorologists in understanding atmospheric pressure and the movement of air masses. It even plays a role in how fish regulate their depth using swim bladders. Without understanding this fundamental force, much of our modern world, from global trade carried by massive cargo ships to deep-sea exploration, would be impossible. It's a silent, invisible hand shaping our interaction with fluids. Here's the surprising truth. The buoyant force isn't just about whether something floats or sinks. It's about the apparent weight of an object. When you lift a heavy rock underwater, it feels lighter than it does on land. That's because the buoyant force is actively pushing up, reducing the effective downward pull of gravity. Every object, whether it floats or sinks, experiences this upward buoyant force. Even a solid gold bar plummeting to the ocean floor is experiencing an upward push, albeit one far too small to overcome its immense weight. This means that nothing truly experiences its full weight when submerged in a fluid. This subtle reduction in apparent weight is a constant, universal interaction. It's a testament to the pervasive influence of fluids and the elegant simplicity of Archimedes' discovery. So the next time you see a ship glide across the water, or feel the lightness of your body in a pool, remember the unseen force at work. It's a principle born from a moment of pure insight, yet it continues to govern the movement of worlds, reminding us that even the most profound truths often hide in plain sight, waiting for a curious mind to uncover them.